Hello, my name is Stephanie Rust, and I'm going to be going over the procedure of performing an unconfined compression test. We are going to need some equipment for this test. We will need a graduated cylinder, some water, a vernier caliper, a mold, an empty bowl, a compaction device, an extraction device, a water content can, spatulas, a calculator, and an unconfined compression test load frame. The first step is to obtain the tare weight of your empty bowl. I have written down the empty tare weight, and I have obtained a sample filling up a good part of my bowl. I am now going to weigh the sample in the bowl. I will record this number. Now that this has been recorded, I can calculate the amount of soil in my bowl. From this amount, I am then going to determine how much water I need to add to my sample in order to reach a predetermined water content defined by your instructor. We are going to use a 20% water content for this particular test. In order to obtain that, I am going to assume that there is already a 2% water content due to the atmosphere and surroundings. Therefore, I'm going to take the amount of soil times 0.18, and I obtain the amount of water that I need to add. It is 68.4 grams, and 1 gram of water is equal to 1 milliliter of water. Therefore, I need to add 68.4 milliliters of water to my soil. I will then add the water to the soil, and I'm going to mix it thoroughly. Now that the sample has been completely melded and mixed, we're going to place it into the compaction mold and begin compaction. I can't talk. Place the soil into the mold as full as you can get it, because it will compact. You see I have it full. Now I am going to use the compaction device to tamp the soil into the mold. Simply use the compaction device to push the soil until you do not notice that it is compressing any further into the mold. As you can see, the soil has compressed very much into the bottom of the mold. We're going to repeat this until the mold is fully compressed. The soil is now compacted to a level into the collar of the mold. It is now complete. I will now remove the mold from the holder and lift it out. I'm going to take the ring apart from the mold, and as you can see, I have my soil. The next step is to ensure that the top surfaces and the bottom surface of the soil in the mold is smooth. Since I have some indentations, I'm going to patch with the soil from the ring.
Keep doing that.
Okay, now that my indentations are filled, I'm going to use a spatula to smooth the surface. The surfaces are now smooth and we are ready to extract from the mold. The extruder will have the handle in the upright position and the mold will slide into the extruder and set in the indentation. The handle is now in the upright position. I'm going to use one swift downward stroke to extrude the soil sample. We are now going to measure the diameter of the specimen at the top and record, the center of the specimen and record, and the bottom of the specimen and record. We are now going to measure the height of the specimen as well, 3 times 120 degrees apart. Write this down. Rotate 120 degrees. Record that. And the final 120 degrees. And record. The next step is to weigh your extruded specimen. Be sure to record that weight. The specimen is now ready to be placed into the load frame. We are now going to place the specimen in the center of the load frame. The next thing that we're going to do is turn the crank in a clockwise direction until the top plate is just touching the top of the specimen. You now must ensure that this pin is touching this pin so that you may get your measurements correct, and we're going to zero this dial. What we are going to be doing is observing these 2 dials as we turn the crank. The first dial is the amount of load that is being applied to the specimen. It is measured in divisions. Divisions are simply the measurements on this dial. Using the calibration connected to your device, you should have a ring constant in the corner of this paper. This ring constant will simply convert these divisions into pounds to indicate how much weight was used to induce failure in your specimen. The second dial is a displacement dial, and it will measure in portions of an inch how much your specimen is displaced as it is being failed. We are going to turn the crank very slowly in a clockwise direction. Every time this needle passes 1, 2, 3, 4, any of the major points, a reading will be taken of this dial. Please note that every time the needle of this dial passes 0, that is 1. So if it passed 0 and is at this point, that will be 1.10. We are now turning the crank very slowly at a rate of 0.25 inches per minute. You must not turn the crank too quickly or you will induce failure before you have had a chance to take your measurements. Once your sample failure has been sketched, you may unload the specimen, remove it from the load frame, and take a water content of your entire failed sample.